In this video, we will explain what engineering notation is. Engineering notation simply uses metric prefixes to represent values that you'd be familiar with. Thousands, we would use kilo, abbreviated with a lowercase k, and that represents 10 to the third, 3 more zeros added to whatever numbers you have. There's millions, represented by mega, abbreviated capital M, right? 10 to the sixth. You'd be adding 6 more zeros to whatever digits you see. Giga, up to billions. Capital G, 10 to the ninth is what you're looking at. The 9 being 9 more zeros or 9 more decimal places added to whatever digits you have. Trillion would be tera, and capital T represents that. You can also go the other direction. Milli here would be thousandths. You would be moving the decimal point to the left 3 places. 10 to the negative third takes away 3 places on whatever digits you have. We'll give you some examples in a minute if this isn't making sense to you. Millionths, billionths, trillionths. Micro, there's this little mu character here, so make sure you have this tail on here. This is on the micro symbol. 10 to the negative 6, take away or move to the left. The decimal point moves to the left 6. And then, of course, nano, lowercase n, and pico, lowercase p, take you in the smaller direction. Real quick, I should mention it's important to distinguish some of these, if you're not careful with your handwriting, can look similar. I'll give you an example. So let's take, so there's a capital M, a lowercase m. Do you see where I'm at? This mu character, even this lowercase n. And I'll show you how those 4, if you're not careful, can be hard to distinguish, which is deadly, of course, if you're trying to pass information from one technician to another or one engineer to another. So look at somebody's sloppy handwriting. Let's see here. I'll do an example. If they were trying to do a capital M to represent mega, and they just weren't real careful about it, might look like something like that, you know. Hard to distinguish between a sloppy lowercase m, right? Hard to distinguish between that micro symbol. Somebody might have been sloppy there, you know, and somebody might have been sloppy with their n, you know, their lowercase n. So I think you see the problem. So pay attention to that. If I can't distinguish on your papers, you know, then that's a wrong answer. So here's a capital M, right? Just take your time and make sure we can distinguish. A nice clean lowercase m, right? That micro symbol has a tail and then the n. Okay, so simple but important to write those characters precisely. Okay, so maybe that made sense or not, but let's do some examples. That'll help you if you sort of still aren't sure how this all works. So let's say we have some real small value that we want to write down. Let's say we have real small current flowing, so maybe only 0.00123 amps. Okay, so an engineer is not going to write it like that, or a technician. There's a better way to write this. So we're going to grab a metric prefix, and it's small. It's a small number. The rule for engineering notation is you should only be writing down digits that show a number between 1 and 999. So look, I can move this decimal place 3 places to the right. But important to remember, you're not allowed to change the actual number. So if I move the decimal places 3 places to the right, 1, 2, 3, I have to pick a prefix that'll maintain the actual number that's there. So, well, it's a lot of talking just to show you, but let's show you how you would write this. This is also, and I'll put an equals here so you can understand. I'm not allowed to change the actual value, but I can change how it's written, and that's what engineering notation is all about. So the better way to write this, or the correct way in engineering notation, would be 1.23. Now that's not amps anymore. That would be milliamps. There you go, and that's engineering notation. You see how I made a number between 1 and 999, but then use the appropriate prefix. Let's do another one. What if it was what if it was this 0.0? Well, I didn't want to do that. Let me do this. Let's say it was just 0.0123. Okay, let's do that just to show you how this works. Okay. Let's say I had 0.0123 amps. Okay, I would still use the milli prefix. My answer, my equivalent in engineering notation is 12.3 milliamps. In engineering notation, you're only permitted to use metric units in multiples of 3. So, I'm not gonna just go over 2. So I have milli available, and I can move the decimal place still 3 places, and my answer in engineering notation is 12.3 milliamps. Okay. And again, you're shooting for a number that sits between 1 and 999. So this is still correct engineering notation. Maybe we can do an example of a large number. Let's say I had a large amount of voltage. I don't know, let's say I have 1,256 volts. So to put it into engineering notation, it would be, I'm in the thousands of volts here, right? So I would use kilo. So this would be written as 1.256 kilovolts. And I think, can you see that they're the same number? This kilo here is telling you thousands. So it's telling you that the actual value is 3 decimal places to the right. You gotta. That's 10 to the third. So the real number is decimal place moved 3 places, 10 to the third, and you've got that 1,256. Another quick example. What if I have 10,000 volts? 256. I could still keep that in there. So in engineering notation, that would be 10.256 kilovolts. Okay. Maybe you can always remember some simple things like if the units are small, then you're going to have a larger number showing in the digits. Or if your units are large, you'll have a smaller number showing. I think that concept should be already in your head. If you had, let's do it this way. we can go back to English units or something. Let's say it had 1 foot, right? Well, if you make the units smaller, right? Let's go down to inches. Smaller units mean this number gets bigger, right? So this is, I mean, I'm just showing this because it helps you in case you get dizzy converting numbers back and forth this way, that way. To clear your head, just always remember that when the units get smaller, the actual number in front of the units has to get larger. If it's 1 foot, that's the same thing as 12 inches, or we can go up to a yard here, and it's going to be a smaller number now for the, for the yard. The unit got larger here, so the number is going to get smaller. It's like, a third, right? There's how many yards is 1 foot? It's 1/3, right? So here we have the example of, just to keep in your mind, we have the example of units getting smaller, number gets bigger. If the units get bigger, the number over here gets smaller. And like I say, that's really just intended to help you if you have to clear your head. You can catch mistakes that way too, so yeah. If we went all the way to take an example up here again, look at our volts. If we wanted to, it's true that you could say that we could take it up to megavolts. What would that be, right? But we're going to take the units from kilo to mega, so the units are getting larger, so the number is going to get even smaller. And in fact, it gets a little too small for true engineering notation, right? So you wouldn't use mega because you're not at a number here that's between 1 and 999. But these are all the same number. 10,256 volts is the same as 10.256 kilovolts is the same as 0.010256 megavolts. Let's see. So the metric prefix is just keep track of the real value for you, but this would be the proper one to use for this example. Truly engineering notation. It sits between, the number itself sits between 1 and 999. Okay. This will probably just be a short video. I don't know that I have to do more. There's handouts that you can use to practice. It's in our book. You do want to get really smooth at this. You don't want to throw away test points, get something wrong on a test just because you got the decimal point in the wrong place. And believe me, that happens a lot. So it can really kill your test score when something as simple as engineering notation isn't smooth. Your decimals just never quite landing at the right spot. So yeah, so we'll practice that, and I'll put together another little video, another simple but something that students trip over sometimes is just getting engineering notation into and out of your calculator. So I'll do another video on that, just showing you the keys you would use, and again, you have to get just really smooth at it. We don't want this to be the hard part. There's plenty of electrical concepts to work our brains on. We don't want your calculator or the engineering notation to be the difficult part at all. Shouldn't have to spend any effort at that. So we'll work problems till you get real smooth at it. Okay.